Another problem, thunderstorm speeds. A meteorologist who sampled 13 randomly selected thunderstorms found that the average speed at which they traveled across a certain state was 15 miles per hour. The standard deviation of the sample was 1.7 miles per hour. Find a 99% confidence interval of the mean. If a meteorologist wanted to use the highest speed to predict the times it would take the storm to travel across the state in order to issue warnings, what figure would she likely to use? Okay, so let's go through it. I'm not sure I care about the last one, but we can try to answer it. Meteorologists who sampled 13 randomly selected storms. So our sample size is 13. It says that the average speed of these 13 is 15 miles per hour with a standard deviation of 1.7. Now notice I use S because it doesn't say the standard deviation of the population, so it's the standard deviation of the sample, even specifically in the problem, was 1.7. And they give us a confidence level of 99%. So in our decision making, do I know what the standard deviation of population, sigma, is? The answer is no. So this is going to be a T interval. Okay, so that means I need one more piece of information, and that's the degrees of freedom, which is n minus 1 or 12. Okay, with that I can look up my T value. I go to 99%, I go down to 12, and I go over and I get 3.055. So my T is going to be 3.055. Now I can plug it in the formula that we use, which is x bar plus and minus t times s over the square root of n. Okay, so x bar is 15 plus and minus 3.055 times s, 1.7 over the square root of 13. Okay, so I plug that into my calculator. 15 minus 3.055 times 1.7 divided by the square root of 13, and I get 13.5 mu, because that's what we're estimating, and then go back up. I don't need to retype everything again. I'll just go in and change the minus to a plus, and I get 16.5. Okay, so the last question, if the meteorologist wanted to use the highest speed to predict the times it would take a storm to travel across the state in order to issue warnings, what figure would she likely use? And the fastest speed would be 16.5 miles an hour. To be safe, really, she'd probably go to 17. Okay, so one other problem in the section about means is sample size problem. This is where you're doing a study and you want to know how many people or things that you want to sample to keep a certain accuracy level. Now, the formula that we had for the z interval was this. Now this piece of the interval that we add and subtract is called the error. And we're going to just call it E. Alright, and so what we're going to do is just solve for n. Okay, so we're going to use this formula that we just created, z times sigma over error squared, to estimate our sample size. Alright, so let's do a problem. A pizza shop owner wishes to find the 95% confidence interval of the true mean cost of a large plain pizza. How large should the sample be if she wishes to be accurate within 15 cents? A previous study showed that the standard deviation of the price was 26 cents. Alright, so let's figure out what everything we have here. Well, the first number they give us is the confidence level, 95% confidence interval. And then they say accurate within. A lot of these problems, when they talk about within, this is the error. This is E. So they want to be accurate within 15 cents. And then the last is a previous study, the standard deviation. So the previous study is the 0.26, the standard deviation. Now the only thing left to do is find a Z. So again, we just go to the table and we have a 95% confidence, and since it's a Z, we slide all the way to the bottom and we get 1.960, and we use that Z. Now we just plug it all in, and so we have Z 1.960 times sigma 0.26 over the error 1.15 squared. Now once we've got it written down right, we get out the calculator and we just plug everything all in, parentheses 1.96 times 0.26 divided by 0.15 squared, and we get 11.54, or 12 pizzas, because we're not going to ever try to estimate half of a pizza, so round up. We'd rather have too many than not enough. Okay, so we need, really, I guess the answer would be we need at least 12, would be a better way to say it. Okay, but for what we're doing, 12.